Lesson 11-1, Univariate Data. In this lesson, we're going to look at one kind of data that you can collect when you're doing some research. One is univariate data. A variable is a characteristic, number, or quantity that can be counted or measured. A variable is an item of data. The data can be described in two different ways. One way is numerical data or quantitative data. Quantitative data has units and can be measured. Data that can be organized into different categories are called categorical data or qualitative data. Data in one variable are called univariate data, are often summarized using a single number to represent what is average or typical. There are several ways univariate data can be displayed, depending on whether the data were numerical or categorical. Each data display has strengths and weaknesses. So again, just to recap, there's univariate data and there's bivariate data. Bivariate we'll get to it with another lesson, but with univariate, you can have it as numerical or categorical. Numerical things, you're measuring it with numbers. Categorical, you're measuring it with categories or characteristics or descriptions. We're going to take a look at some different kinds of displays. First display is a bar graph. A bar graph just compares categories of data using bars of different heights used to display categorical data. So you're going to have your categories down to the bottom here, and here's always what you're measuring by. It's like your numbers. Now that each of these displays that we're going to be looking at today, you have some strengths and weaknesses. For a bar graph, the strength is it's easy to compare the categories. So according to this one, we can say that B has the most number of students and F has the fewest amount of students. So you can compare that way. But the weakness is it does not allow for easy comparison of a category with the whole data set. So if you're comparing B towards what percent is B of the whole, all the students, that wouldn't be very accurate there. That would be used for another type of display. So if you're just comparing individual categories, then you can use a bar graph. Next one is a circle graph. Shows the relationship between parts of a data and the whole. It is used to display categorical data. So here you can see our categories: fishing, campfire, cooking, hiking, and boating. And then you'll notice that there's percents in there. If you add them all up, that equals 100%. So here you can easily identify, like, campfire cooking is 28% of the whole circle. So out of all the four activities, you can see how big campfire cooking is compared to the rest. And you can see that hiking has a bigger pie piece, but that would be more of the pie circle than any of the other pieces. So the strength, it's easy to compare, make comparisons of the categories within the whole data set, but it's not appropriate for data sets that do not represent the whole population. So like the previous example, you wouldn't use a pie circle for that because we don't know what percent each letter grade was compared to the whole class. Next is a stem and leaf plot. Stem and leaf plot is a table that organizes data by place value to compare data frequencies. The digits of the least place value form the leaves. So like the very first decimal, or not decimal, place value. So if I have the number 154, the 4 would be our leaf. And the rest of the digits form the stems. So 15 would be our stem. So if I were to read the stem and leaf plot that I have here, I can look at the key here, and the key tells me 1 with this bar here, 4 means 14. So I would read this as 14, 18, 19, 19, 20, 21, 22, 27, 28, 31, 32, 33, 33, 36, 37, and so forth. One of the strengths of using stem and leaf plots displays individual data points, so we can see how many points we have collected. It can be difficult to visualize any trends. So is this trends or are there different orders? Does this mean and you can see that the 30s have the most numbers, but like any other trend, it would be very difficult to visualize compared to like a bar graph where you could visualize that. And it's also difficult to use with large data sets. So here, if you have a smaller amount, then you could use a similarly plot. But if you have like 100 data points, it probably would not be the best way to use a stem and leaf plot to display that data. Next, we got a dot plot. Dot plot is just a diagram that displays how the data values are distributed, where the frequency of data is shown on a number line. It is used to display categorical or numerical data. You probably see this more so with numerical than categorical. Constraints, useful to show clusters and gaps, useful to show trends in the data, but it may display individual data points. It may be scaled by intervals, but it's difficult to use with large data sets. Plus, if you don't have numbers that repeat, then you probably wouldn't want to use a dot plot, because this is telling you 0 was mentioned 1, 2, 3, 4, 5, 6 times. 1 was mentioned 1, 2. 2 was collected 3 times, and so forth. And there you can see the trends. Or if there's no dots above there, you can see that that would be a gap. But if you have like 100 data points and nothing repeats, or very few repeats, then it would be very difficult. You'd have to have a larger number line for that or determine what you're going to do by intervals. But there are other data displays that would be more appropriate. Next is a box plot, or a box plot is a graphical representation of the 5-number summary. 5-number summary is the minimum quartiles, like your first quartile and your third quartile. You got the maximum. It is used to display numerical data, so just numbers here. So the measures of central tendencies, when they say measures of center, you're talking about the median. You wouldn't be able to see the mode on there, but you can do the minimum and the maximum. The spread is how far the range. So here we can see that the lowest number is 5 and the highest number was 30. This number in the middle here, this dot, that would be the median. The median would be roughly 22. Shows how data is distributed in the range, but it doesn't show whether the data has gaps or clusters. We don't know how many data points there are in here. We just know really what the range is and what the median would be. It does not display individual data points. So I don't know if there's a point here, a point here. Maybe there isn't any point in there. Is there any points out here? We don't know. The only thing we do know for sure is 5 is the smallest, 30 is the largest, and we have a point here, and this point right here is like the median of the first half. Here's the median of the second half. Half of the data points are in this box. That's as much as we know. Anything else, more specific details, we would not be able to determine from a box and whisker plot or a box plot. Next, we have a histogram, just another bar graph along a number line with no spaces to display numerical data that have been organized into equal intervals, and they call those intervals bins. Used to display numerical data. Here you can also use it to find trends and make comparison in the data. It does not display individual data points. We just know how many numbers are in each bin. So here, this is saying that there are 2 numbers between 40 and 44. We don't know what those numbers are, but they are in those intervals. The one thing that these intervals must be the same throughout. Now let's take a look at example 1. Here we want to determine whether the data are numerical or categorical. So letter A, the ACT scores of all test takers in a particular year. Since you are looking at ACT scores, scores are listed as numbers, so we would call this numerical. Letter B, the percentages of students in a school who walk, drive, or take a bus to school. So what are you comparing? Yes, we were comparing percentages, but we were really comparing categories. We're comparing those who walk to those who drive and those who take a bus to school. So this would be categorical. And letter C, the daily height for the month of April. Here we are just listing numbers, so this would be numerical. Other examples, the percentage take a bus or carpool to work. This one be very similar to letter B from the previous slide. So you are comparing categories, so this would be categorical. The ages of members in a local show. What are you collecting? You're collecting ages, which are numbers. And the number of students who participate in the 4 most popular after-school activities. So you are dividing them into categories. And the categories are the 4 most popular after-school activities. So this would be categorical. Next, determine whether the data are numerical or categorical in these examples. There's the number of customers who purchase each of the 8 most popular flavors offered at an ice cream shop. So they're finding numbers who chose each flavor. So since you were dividing it by flavor, that would be categorical. The ages of the participants in a community theater group. So you're only looking at one group, you're just collecting their ages, so that's numerical. And the number of runs scored by the school baseball team in each game of the season. So you are collecting runs scored, so this would be numerical. And for this one, somebody could make an argument that it could be categorical if you are breaking it down by games. So a game versus this team versus this team versus this team. And so I could see that could be categorical. So we could say this is numerical or categorical based on what are you dividing into? Are you dividing into individual games? And that would be like teams that you're playing, or are you just looking at the numbers that you're scoring, which would be numerical. Next, example 2, make a data display to show trends in how the given data are distributed. Trends, one of the displays that would be best for showing a trend would be a histogram. So for this one, I would probably draw a histogram. This one is showing numerical data. So numerical data is used with histograms. So let's draw a histogram here. And our bins, let's count our bins by tens. So my smallest number here is 18. So I'm going to go from 10 to 19, and then 20 to 29. Then I would have 30 to 39, 40 to 49, 50 to 59, and we would have 60 to 69. Then our vertical axis, this would be our number of days. So let's just count by, we'll count by ones. So here's 1, 2, 3, 4, 5, and 6. Then we're going to draw bars for each of the categories. So we have between the 10 and 19. We'll use a red bar for this one. So we got 1 here, 2 here. There's only 2 between 10 and 19, so we'll draw a bar here. between 20 and 29. 24 is one of them, and that's it. So we have one of them, 30 to 39. Got 30, 37, 37, 38. So that's 1, 2, 3, 4. Next, we got the 40 to 49 range. So there's 1, 2, 3, 4, 5, 6. Then 50 to 59. That'd be 1, 2. And then our last one, 60 to 69, we got 1. So then this would be our histogram. Next here we are showing trends and with these given test scores. So again, I would show a histogram for this one. So draw our histogram. Here we'll count by ones again. 1, 2, 3, 4, 5, and 6. And we will go in groups of 10. We'll start with 61, 70, 71 to 80, 90 or 81 to 90, and 91 to 100. So the first one between 61 and 70, we got 1, 2. We got 2 of them. Between 71 and 80, we got 1, 2, 3. So 3 there. 81 to 90. We got 85, 86. And that looks like it, so just 2. And we got from 91 to 100. So there's 1, 2, 3, 4, 5. So then there would be our histogram to display the data with that table. Next, select the best data display. Compare each category to the whole population. So the whole population means you're comparing it to the whole thing. So here are our choices. We got a leaf plot, we have a box of whisker plot, we got bar graphs, and we got a circle graph. Well, the one we know that compares to the whole population or the whole group would be letter D, the circle graph. Example 3. The table shows the total number of Olympic medals won by U.S. athletes competing in select events from the first Summer Olympics in 1896 through 2016. Make a display of the data to show the total medals won for each event. So we have the events, and we're just doing the total amount of medals. So we have to add up all the ones from each of these rows, for each of the categories. This is categorical, which would mean we'd probably best use a bar graph. So I'll draw a bar graph here. And we will have 1, 2, 3, 4, 5 categories. So we have boxing, we're going to have diving, we're going to have swimming, we're going to have track and field, and we're going to have wrestling. And our Y values, or our vertical axis, let's count these by 100. So this would be 100, 200, 300, 400, 500, 600, 700, and if we have to go up to 800, we'll go up to 800 as well. So let's go first for boxing. For boxing, we add 50 plus 24 plus 40 gives us 114. So 114 for boxing, that'd be a little bit over the 100. For diving, you got 48 plus 43 plus 44, that's going to give us 135. 135 would be a little bit past that for diving. For swimming, you got 246 plus 172 plus 135 gives us a total of 553. 553 for swimming, this height. For track and field, you got 332 plus 257 plus 202 gives us 791. 791 would be almost 800. And then wrestling, 54 plus 43 plus 35 gives us a total of 132. So this would be a little bit shorter than the blue, but bigger than the green. So we can go roughly here. So there would be our bar graph used to compare the number of medals each event won in the Olympics of 2016. Or not 2016, from the very beginning. Next, a survey was conducted among students in Mrs. Dobson's class to determine the learning styles of students. Results are shown in the table. Determine whether the data shown are categorical or numerical. Then make a display of the data to compare the votes to the entire class. So here's the key part, to the entire class. So you compare it to the whole group, means we're going to draw a circle graph, means we need to have a percent. So to find the percent, I need to know the total number of votes. If I add up all the votes, that's 14 plus 6, which is 20. So I have 20 total votes. And if I divide everything by 20, I would get my percent. So 6 out of 20 would give us 30%. 8 divided by 20 would give us 40%. 4 divided by 20 would give us 20%. And 2 divided by 20 would give us 10%. And if you were to add them all up, that would give you a total of 100%. Now, the first question is this categorical or numerical? Here I have categories here, so this would be categorical. And then I draw a circle graph. I need 4 pieces. I would start with, I could cut this in half because I know I have a 50% with visual and reading and writing. And they're not quite equal. One's 30%, one's 20%. So this would be 30%, and this would be auditory. 30% is visual. That means this 20% would be reading and writing. That means the other side is 50 because we have a 40% and the 10%. So this would be the 10%, and 10% is kinesthetics, and it means 40% would be auditory. So there would be our pi circle with a just rough estimate of what our pi circle pieces would look like. Next, the table shows the number of active video game players in each country. Make a display of the data to compare the number of players in each country. Since I'm not comparing it to everybody in the world, I would just use a bar graph because we do have categories that we have here. So that answers one question. So it is categorical. Because it's categorical, I'm going to use a bar graph. And a bar graph would work best because we're just comparing numbers in each country. We're going to draw a quick bar graph on the next slide here. So our bar graph. Down here we'll have Australia. We got Brazil. We have Germany. We have the UK. And we have the US. And then we're going to count by 20s here. So 20, 40, 60, 80, 100, 120, 140, 160. And then let's go back to here. So Australia, 9.5 million. Again, these numbers on the side are in millions. So 9.5 would be a little bit half. Brazil was 40.2. 40.2 be about the 40 mark. Germany was 38.5, a little bit below that. And the UK was 33.6. And then the US was 157. That's going to be a little bit below the 160 mark. Okay. And there will be our bar graph. Next, the data display shows the results of a survey of 14,776 readers and their preferred book format. State whether the data are numerical or categorical and interpret the data display. Since we are doing the whole population or whole group of readers and their categories, they're separate by categories by their preferred book format. So this is categorical. And then we need to interpret the data. Now, when you interpret this data, there are multiple ways of interpreting. You just need to come up with a couple interpretations that can be proven by the bar graph. But based on this, new print was most preferred. Because that was 39%. We could also say audio was least preferred. And that was 5%. Now we could do other ones, but I just wanted to give you a couple ideas of what you could put down for your interpretation. Next, the data display shows the price of meals offered at a restaurant. State whether the data are numerical or categorical and interpret the data display. Since this is a box and whisker plots, you only use box and whisker plots with numerical data because you're just looking at the numbers. So now in interpretation, we can say that the least priced meal was $9.50. And the most expensive meal was $22. So that would be just a couple of interpretations I can make based on that box and which one. In our last example, 2 six-sided dice are rolled 25 times. Some of the dice are shown in the data display. Say whether the data display are numerical or categorical, and interpret the data display. Since a number cube is made up of numbers, we're just collecting numbers, so this would be numerical. And interpret the data. We could say that there are more sums of 6 and 9 compared to sums of 2 and 4. That would be one interpretation we could have. We could also say that 7, or the sum of 7 showed up 3 times. So again, your interpretation should be proven by your display. That is our lesson on univariate data.